All right, so I want to use this video to walk through the process of calculating confidence intervals and then walk through two examples. You can find more practice problems in the module itself. So we walked through the procedure of calculating confidence interval if you know the population mean and standard deviation. This formula was simple, but it's not the most accurate or most realistic type of problem compared to what we deal with in the real world. So if you only have the sample mean and standard deviation, much more common, you do things similar but slightly differently. So the biggest thing is that you're not going to use the z-score like you're using before. You're going to use the t-score and the t-score table. How you use this is slightly different from the z-score, but it should be intuitive and it follows a similar enough process. Um, for this, degrees of freedom are very important. That's your sample size minus one. So what you do is you scan down the first column on the far left. That'll be your degrees of freedom. So you identify where you reach the right degrees of freedom. So your sample size minus one. And then you choose the appropriate alpha value, which is the column header, so that top row. You find where those two meet, and you plug that value into the equation, and then you use it to solve. So and click yes. Here is an example of the t-table. So here, find my cursor. You have the degrees of freedom right here, ranging from 1 up to 30. Then above 30, we just have the z-score. So t-scores are good for small sample sizes. And you can see, let's skip the first couple, but even down here, like 6, 7, 8, 9, these numbers start like 0.26 here, and then they shrink as we go down, as we increase the sample size. So as you increase the sample size, you're more comfortable with these, with the estimates here. You don't have to have such a large number for that. Now across the top here, we have the alpha. Down on the bottom, we have the corresponding confidence interval. So you can just look at that. So if we say we have 95% confidence interval, we go to this column right here. So 0.25 split both ways, or 95%. 99% would go over here, and so on. So say you had 24 as your sample size, you would do 24 minus 1, so 23 degrees of freedom. And say you had 95% confidence interval, you would trace this 23 over to the 95% confidence interval, and it would be 2.06866. So that's how you identify a confidence interval. So let's walk through a quick practice problem. So as looking at the MIT basketball team, let's say the scores are normally distributed, but we don't know the mean and we don't know the variance of like all the games. So if we look at the last 10 games, so MIT scores the following set of points. So the problem would ask us to compute a 95% t-confidence interval for the population mean. And we can skip the second part of the question. What does the 95% mean? Let's just focus on calculating it. So we have sample mean of 65 and the sample standard deviation of 35.778. So what we have to do to solve this is we have to find the t-score, plug in the numbers that we have, and solve. So our sample mean is 65, our sample standard deviation, 35.778. We have 10 games, so that's our n, sample size of 10, and our alpha is 95%. So for degrees of freedom, that's n minus 1, so that would be 9 degrees of freedom. So we trace down here to 9. And then we are doing a 95% confidence interval. So with the two-tailed test, it'll be 0.025, or simply go to the bottom to the 95%. So we cross that column and that row for the degrees of freedom. We end up with 2.26216. Round that to 2.262. If you don't have to work with all of decimal points to be slightly off, but close enough. For our purposes here. So this is the equation. The equation in the slides in the module has t alpha divided by 2 comma n minus 1. That n minus 1 is the degrees of freedom. Alpha divided by 2, is this value up here. A simpler way to write it is with some ugly handwriting. Confidence interval is x bar plus or minus the t-score times the sample standard deviation divided by n, the square root of n. little bit easier when you write it that way. So the mean 65 plus or minus the t-score we said was 2.62 times sample standard deviation of 35.778 divided by the square root of 10. We can split that up so we have the minus side here and we have the plus side here. When you do all the math, you get the mean is between 60.721 and 69.279. So the mean is somewhere in between these. This is the 95% confidence interval. So the problems are fairly straightforward. It is once you find the t-score, it's plug and chug. You put the numbers in there. Feel free to write this equation rather than all of this junk here after t. If it helps you keep things sorted out, keep things simple, that's totally fine. Looking at another problem here, let's say the mean is 123, the sample standard deviation is 15.8, but now our n is much larger, it's 150, and our alpha is the 99% confidence level. So to do this, we're going to trace down the degrees of freedom. So our degrees of freedom is 149, 150 minus 1. Notice that our t-score only goes up to 30. If we're going above 30 in the t-score, that's when we use the bottom column. Apologies, we use the z-score here at the bottom. And now we're doing a 99% confidence interval, so trace that z, that bottom column, the largest number across so we get 99%. And that's right here, the 2.57583. So let's just plug everything in and go ahead with it. So the sample mean is 123. The t-score is 2.5758. And then we have 15.8, our sample standard deviation, divided by square root of n, the square root of 150. Again, doing the math, we end up with 119.677 and 126.323. This time it's much more tightly clustered around the mean. We have a much larger sample size this time, and compared to the standard deviation, it's much smaller. So I'm going from like 35 down to 15. Because the standard deviation is smaller, it's going to be more tightly clustered. Standard deviation was larger, it would have a wider spread around the confidence interval. So hopefully walking through those problems like this will help you understand how to do confidence intervals. This is something that's fairly important in statistics and in this course. If you have any questions with this, feel free to reach out to me. And of course, there's going to be more practice problems with the solutions for you to work through.